All right, in this video, we want to find the critical points of these questions over here, and then we want to find the intervals of increase and decrease. So let's start with this first question over here. Now to find my critical points, I need to derive the function. I know this is a product rule here, so I'm going to do my product rule, which is f prime g plus g prime. So I know f is my first function here, which is x squared. G is my second function, which is e to the 3x. F prime is just going to be 2x, and g prime is just going to be e to the 3x times the derivation of the exponent 3. So just 3e to the 3x. Then I can put this in my product rule. So I'll do it on the side here. So f prime x equals f prime times g is just 2x e to the 3x, and g prime times f is just plus 3x squared e to the 3x. Then I want to factor this and make it equal to 0 to solve for the critical points. So over here, I can common factor out an x, and I can common factor out e to the 3x as well. And I'm left with 2 plus 3x. So now my first critical point here is x equals to 0. An e function can never equal to 0, so that'll have no solution. And over here, my second solution is negative 2 over 3. So I have two critical points in this function. I want to put them in my number line. And I'll put negative 2 over 3 first, which is my first critical point, and I'll put 0 second, which is my second critical point. So now I want to find my intervals of increase and decrease. In order to do that, I have to test these three intervals over here. Let's look at the first interval. You can pick any number from the first interval. I'm just going to pick negative 1. So I'm going to sub in negative 1 into my derived equation. I'll use the simplified version over here because it's a bit easier. So if I have negative 1 times e to the negative 3, that's still going to be a negative number because e is always positive. This is all going to be negative. Then 2 plus 3 times negative 1 is also negative. So I have a negative times a negative, which is a positive value, which means that my graph is increasing in that interval. Pick a value between these two. I'll pick negative 0.1. If I pick negative 0.1, this is negative. This is always positive. So negative times positive is negative. And then 2 plus 3 times 0.1 is positive 1.7. So I have a negative times a positive, which is negative, means my graph is decreasing. Over here, I'll pick positive 1. If I pick positive 1, this is positive, this whole thing is positive, which means that it's going to be positive in the end. This is increasing. So my intervals of increase are from negative infinity till negative 2 over 3, and then from 0 till positive infinity, and my intervals of decrease are just negative 2 over 3 till 0. Let's try the second example over here. Same idea, except this is a quotient rule question. Quotient rule is f prime g minus g prime f divided by g squared. So f is just the function on the top, which is ln x. G is just the function on the bottom, which is x to the 5. F prime is just 1 over x. G prime is just 5x to the 4. And now let me sub it in my quotient rule. So f prime times g 1 over x times x to the 5 minus g prime times f, so 5x 4 ln x divided by g squared. Now, before I continue this, one thing to mention in this question here is we have two restrictions. I know from the bottom that x cannot equal to 0. I know for a ln function, x has to be greater than 0. So in this question, my domain is just x is greater than 0 if I combine these two over here. That's important to keep in mind for our number line. Let's come back over here to this and keep solving for our critical points. So I'll make this 0. 1 over x times x5 is just x4 minus 5x4 ln x. And the denominator is just going to simplify to x to the power of 10. Now I can common factor out x to the power of 4 from the top. So 0 equals x to the 4, 1 minus 5 ln x divided by x10. Then I can simplify these two and cancel this and turn this into a 6. So 0 equals to 1 minus 5 ln x over x6. Then I can multiply the x6 on the other side, which just means it's going to be 0 equals 1 minus 5 ln x. Move the 5 ln x to the other side. I'll divide by 5. And then to get rid of the ln, when I move the ln to the other side, it just becomes e. So the opposite of ln is always e. So x equals to e to the power of 1 over 5. That is the only critical point that we have in this question. So now when we're doing our intervals of increase and decrease, I only have one point over here, which is e to the power of 1 over 5. But remember, our domain for this question has to be x is greater than 0, which means our minimum value in this question is 0. Now we can test out our number line, and I will test these out into this equation right here. This is the best equation to use. You can't use that one after you get rid of the x6, although it won't really matter in this example because the denominator is always going to be positive. So 0 and e to the 1 over 5, I'll just pick 0.1. That's definitely going to be in between these two. So if I sub in 0.1 into this equation, 1 minus 5 ln 0.1 divided by 0.1 to the power of 6. So this is definitely positive here. Ln of 0.1 is a negative value, because if you remember your ln graphs, a ln graph looks like this, where this is 1. So anything between 0 and 1 is going to be negative. So I know that ln of 0.1 is a negative value. Negative times negative 5 is positive. So the numerator will be positive. The denominator will definitely be positive because the exponent is 6. Positive divided by positive is positive, which means the function is increasing over here. And then let me sub in a value bigger than this. I'll just sub in 10. If I sub in 10 into this function, ln of 10 is a positive value because it's past over here. Anything past 1 is going to be a positive value for ln. So 1 minus 5 times ln 10. So ln e is exactly 1. E is 2.7, which means ln 10 is definitely bigger than 1. So this is going to be 1 minus 5 times a number bigger than 1, which is definitely going to be a negative. Bottom's still going to be positive. Negative divided by positive is negative, which means that the graph is decreasing for the rest of the time. So our intervals of increase, remember we only have one critical point. Our interval of increase is just from 0 till e to the power of 1 over 5, and our interval of decrease is from e to the power of 1 over 5 till positive infinity, because this graph goes all the way till infinity. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.